Okay, so we are going to be working on stats and probability this unit. We're going to start with chapter 6. Chapter 6 and chapter 7 make up our content for unit 5. Unit 6, or chapter 6 specifically, is about univariate data. So univariate data, this is on that front page on the top there, is data which has only one variable. Okay, so we're looking at data that only has one variable. So we're going to be counting things a lot of times, or we're going to look at scores. We're not going to look at like distance and time. We're not looking at two things controlling each other. We're just looking at one specific amount of information, typically something that we can count. Not always, though. Maybe we have to measure it. So in order to go through this, we're looking at some review data that you guys have done before with statistics. We're looking at bar charts. So this is a bar chart. A bar chart has spaces between them. And then we're also going to look at histograms today. Histograms are connected. A lot of times it's continuous data. And we're going to formalize all this in our notes today. And then reminding you what the mean, median, and mode are. Mean is the average. You add them all up and divide by however many there are. Mode is the number that occurs most often. So we find which one occurs the most. If there's more than one, that's fine. It can be bimodal if there's two of them. But we can have multiple modes. Median. If you want the median, it's the middle value in the ordered data set. You have to put it in order first. Then you're going to find that middle number. If there isn't a middle number, then you average the two numbers in the middle. Okay, and that's how you find your mean. So skills check, going through your answers here. So in 1A, when you add them all up, if you haven't done this yet, pause and then do this. Once you do, go ahead and check your answers. So for part A, we want the mean, so we add them all up and divide by 5, and we get 4. For B, we add them all up and divide by 7, we get 11. The mode for number 2, the mode for 2 is just 5. It's the only one that repeats. In B, 1 and 7 are both modes. And then in 3, we wanted to find the median of the data set. So the first one's already ordered for us. So we can just find that middle number at 6. Otherwise, going through, so if there's an odd number, it's always, again, that middle number. If it's even, you have to average the two. So for instance, if there was no 8, it would be 5.5, because it would be the number between 5 and 6. And then for 3, we do have to put those in order first. And so then the middle two numbers are 5 and 7. So we add them together, divide by 2, and we also get 6 for our median there. Questions on like the basic stat stuff. In 6.1, we're going to do a lot of vocabulary. Okay, really making sure that we understand what this is. For some of you, the stats that we're going to do is really familiar. You've done a lot of stats heavy work. A lot of times it's even in pre-algebra. It's not even in algebra necessarily that you do some of the stats. Other stats is in algebra. But otherwise, after that, we don't really do a lot of stats again until like your pre-calc-ish type of class. So some of this stuff is going to be super familiar for some of you, and others of you, you've never seen it before. Again, I'll go through it. Obviously, mean, median, and mode is something that we expect you guys to know how to do. But we're going to get into standard deviation. We're going to get into variation. And some of you don't remember what that is. And maybe you haven't seen it before. We'll go through how to do it by hand. We'll also go through how to do it in your graphing calculator. Super important. When we get to that, that is in 6.4, I believe it is. You need to make sure you have your calculator so you know what it looks like. Because all of the 84 color editions even are just ever so slightly different. So I need to make sure that you know what it looks like, in terms of what we're looking for. And especially the next unit that we're going to do a lot of calculator work there, and you really have to know what your calculator is telling you. And if your calculator has some really funky stuff compared to what mine is, we might be able to update your operating system and make it a little bit more user-friendly for you too. So when we get to that point, don't be afraid to go, hey, mine doesn't look like that. We'll try to update your operating system. I think all of you have 84s of some sort, which is perfect. The Inspire should be just fine as well. In 6.1, we're going to be looking at data that's called quantitative. So quantitative data is data that can be counted. One, two, three, etc. We work with a lot of quantitative data. especially when we're working with mean, median, mode. We're working with histograms, bar graphs, all of those. We need to be able to physically count whatever it is that we're working with. It's not always easy to count because our quantitative data can be discrete or continuous. Discrete meaning we can physically count one thing, two things, three things, four things, and there's a set number of them, whereas continuous means it can keep going forever. So an example of this, so for discrete data, this is data that has specific values. Even though it could be infinite, it could be things like number of people. It could be the number of desks. It could be your shoe size. So for instance, I wear a size 9.5 shoe. There's a 9.5, there's a 10, there's a 10.5, there's a 6. Okay, it has discrete data values. But then there's continuous data, or the data that it's not restricted. The data that is not restricted, such as the temperature. We might say it's 65 degrees outside. However, it really could be 65.102 degrees. Like there's no restriction to what the temperature is. We'll say typically it's 65, but it's not exactly 65 degrees. Another one that's not restricted would be weight. So you can do pounds, you can do ounces, you can do grams, you can do all these different things. And it doesn't have to be even to that extent. We could say 125.9872 pounds or something like that. Again, it's unrestricted, it keeps going. Also, the length of your foot. I wanted to pick these two as the last one. Length of foot. But you can understand the difference between continuous and discrete. My shoe size is discrete. I can only buy shoes in certain sizes. However, the length of your foot is continuous. Everyone that wears a size 9.5 does not have exactly the same length. Some of us might, but not everybody will. So therefore, your length, it keeps going. Okay. Questions on the difference between discrete and continuous? When we're looking at data, we're going to collect data, we're going to analyze data, we're going to collect data. We need to know that our data is reliable. So if our data is reliable, you need to be able to repeat the data collection process and obtain similar results. For example, you could repeat a survey and obtain similar findings. So what we're looking at is if it's reliable, I should be able to, if I'm going to give a survey out to the student body, if I give this survey out to the student body on Monday and I give it out the following Monday, my results should be similar. If they're not, it's not a reliable survey. Let's say on the one Monday I gave it out, everybody was here and we were talking about how many people are getting a job this summer. Okay, and then I give it out the following Monday and it happens to be senior skip day. Okay, is my data going to be reliable? No, because I've changed who I'm looking at now. I took all of those seniors out who possibly are starting new jobs, careers, because they're going into the workforce, or who are really trying to work and save money for college or whatever it is. I took out all those top students who probably are going to be working. So now my data is no longer reliable. So we need to be able to look at what situation it's under. And there's going to be some things that are going to skew our data. It also has to be sufficient. If there's enough data available to support your conclusions. So for instance, I can't just randomly ask one person and assume that answer works for everybody. I have to have a big enough sample so that it can be sufficient enough. So unreliable data can be caused by missing data. Maybe we only asked a certain group. If I was trying to figure out, for instance, how many students rode the bus. If I ask just our freshmen, is my data reliable? No, because there's way more freshmen that ride the bus than juniors. Okay, so that data would be unreliable because we missed data set. We missed people that we should have asked. We also can have errors in collecting data. Maybe whatever it is that we're collecting, we gave it out, I don't know, I'm trying to think of an extreme case. We gave it out in versions of green, so therefore anyone who's colorblind would have a hard time maybe being able to answer it because they can't read that part of it. So again, that's an error in the collecting of data because we don't know. Or maybe we handed it out and we tested the whole student body and we lost half of our data. We just didn't put it into the computer. We're like, we typed it enough, we're going to exclude this. Okay, that's where you're going to have some unreliability as well. Population versus sample. So the population consists of every member in the group that you want to find out about. A sample is a subset of the population. Okay, so you need to know these words. These words are going to be very, very important. Population is everybody. If I wanted to figure out what happens in the student body and I wanted to know exactly, I would have to ask every single student. That includes kids who were missing the day I gave it. I need to make sure I include them as well. But sometimes that population is too big. We can't make that happen. So instead, we're going to sample a small group. That is a subset. There are different equations that are used for population and samples. Different equations are used. So with that said, when we're looking at a sample, we have to make sure that our sample is representative of it. So again, if I wanted to find out how many students are riding the bus to school, the sample cannot just be block A in the math department. Okay. Or it can't be specifically, I'm trying to think what class is heavy in terms of, I think block A and B are heavy in our freshman classes because those are our algebra classes for the most part. So we wouldn't want to do that, or flip it. We don't want to do a block D because we don't have a lot of freshmen in there. So just trying to make sure that we're including as many people as we possibly want. So we can get a bias, which occurs when a sample is not representative of the population. Everything I'm talking about right now are things that you have to take into consideration for IAs. So eventually, when you do your math IA, you may be collecting data. You have to make sure, to the best of your ability, that your sample is not biased. Okay, and that's stuff that you actually write about in your IA. This is how I sample people. Again, if that's the route you're going, you don't have to go that route, but if you do, you have to make sure that the sample that you're looking at is representative of the group that you specifically want. Now, maybe you only want to sample students who are in band, okay, and it's specific to our band students. You would narrow down your population to just students who are currently in band. Or maybe you only want to look at our freshman class. Then you would narrow that down to freshmen. So it might not be something where you want the entire student body. It might make sense that it's a specific group, and that's all laid out in your work. Why did you sample who you did? Like, what was your goal there? So when we have to do some of those restrictions, there are these things that are called sampling techniques. Again, the likelihood they're going to ask you, was this a systemic sampling or was it a quota sampling, is slim to none. They may say we did a blah, blah, blah sampling, but they're not going to be like, well, which one is it? So with our sampling techniques, ideally, you will do 2 of these at one time for it to be a good sample. So you'll do a convenience sample and a systemic sample or something along those lines. So I'm going to define what each of these are. Just know if you are going to run a, if you're going to sample something, okay, whatever it is, whether it's a survey or whatever the case is, When you are sampling, keep these in mind. These also get written into your paper. I used a convenient sample and a stratified sample because of fill in the blank. Okay, so we'll talk more about that when we talk about our IAs. So a convenient sampling is select members who are easiest to access. So for instance, my class. If I was going to sample like the student body, I might just sample my class. Now, sometimes that's good, sometimes it's bad. If I have all accelerated students, do I have a good group of students to sample in terms of mixing people up? No, I have strong math students. Now that might not matter if we're talking about social studies. It might not. But if I'm talking about math and where students are getting in math, that's not a good sample, but it's convenient. I see you every day. Okay. The second type of sampling is a simple random sample. Each member has equal chances. I'll give you an example. So for instance, names from a hat. Everybody is in there. Everybody's in there. I'm going to randomly pick people. Or a random number generator. If I were going to try to pick people up in the hallway, if I did it during passing period, it might be okay, but maybe I'm getting them coming from math class and I just have all these students that just came from math. Okay, maybe if I stood by the front, it might be a little bit more convenient. It just depends on what my sample is about. So if it's something math related, I don't want to sample students that just came out of math. Okay, so again, just trying to make sure that it's as random as possible. Systemic sampling. What you're going to do is you're going to list out members and select based on a starting point and fixed interval. So again, everybody has a number. And I'm going to start with whoever is number 7 on the list. And then I'm going to pick every 14th person. So again, it's ordering everybody, starting with a specific number, and then every 14th person, I'm pulling them to give them my survey. One is stratified sampling. You're going to divide the population into smaller groups. Which we call strata. And then pick a random sample from each. Okay, so in the example for this one would be, so I'm breaking my population into smaller groups. So I'm going to have a group of 9th graders, I'm going to have a group of 10th graders, I'm going to have a group of 11th graders, and I'm going to have a group of 12th graders. And what I'm going to do is I'm going to pick 25 9th graders, random sample. I'm going to pick 25 10th graders, 25 11th graders, and 25 12th graders. Okay. I could also split it by gender. Stats does a lot of gender stuff. So I can split into male and female, and then I'm going to pick 10 from here and 10 from here. Okay. And then we have quota sampling, which is similar to stratified. but now it's a sample proportional to the group size. The example with this one, so quota sampling would be, so if I have within my group of ninth graders here, I'm picking 25 students, I might bring that down even more. So like, I might end up doing, so like within those ninth graders, maybe 60% are female and 40% are male. So I'll make sure the ones that I pick, 60% of them correspond to female and 40% of them correspond to male. What do you mean? So moving into the math part of things. So 6.2, presentation of data. So now we're going to actually start looking at some of this data. Most of these have already been sampled for you, and we're just using the data that they collected. So you studied the mark of 32 students who took a test, or I should say you are currently studying the marks of 32 students who took a test with a maximum mark of 10. They use marks for IB, so we talk about scores, they call them marks. Their scores are listed below, so between 0 and 10. They nicely put them in order for us. What we're going to do is we're going to construct a frequency table for this data and then draw a bar chart that goes with it. So this is the start of our stats, because then I'm going to use that frequency table for other levels of stats. So we need to make sure we know how to make a frequency table. So for our frequency table, on the left-hand side is going to be score, and on the right-hand side is F. That's what we use for frequency, F. Then on the left-hand side, we list all of the scores. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, when data goes like this in order, if one of them has a 0, you can put 0 as a frequency because it just makes sense to keep going with it nicely. Okay, so what I want you guys to do now is count the frequency. So how many zeros were there? There was 1. How many ones were there? There were 2. Do the rest with the other numbers and fill in your frequency chart. This graph or this data is discrete. So since this data is discrete, we're going to be drawing a bar chart which has the spaces between them. If it was continuous, we would have a histogram typically, and there are some differences between those along the way, but that's kind of the general one. So when we graph this, frequency is on the y-axis, the test score is along the x-axis, and I'm going to label that S, and then of course the frequency is what the frequency is. So when I look at the frequency, it goes from 1 up to 6. So make sure our heights can go up to 6. And then horizontally, we're going to be putting our scores here. So here's how this works. When we have a frequency table, our x-axis doesn't have to come by number. It could be color. Like it could be red is the first tick mark and blue is the second tick mark, etc. So it just depends on what it is. When it's numerical, it does go in order. So we start with 0, and there is 1 0. So go halfway around each side of the 0 up to 1. And then we space it over. Then we do 1, 2, all the way up through 10. And then when we make our bars, so at 1, it's 2. We put a space in there. We come up to 2, and we come back down. And then for 2, that's at 3, so there's a little space. We go up to 3, and we come down. So keep doing that for all 10 of them. When we make graphs, we need to title them. So this one would be class score. We need to get into a good habit of labeling our x-axis and y-axis and titling all of our charts. And this is going to be consistent. Yes. So talking about bar charts versus histograms, bar charts are typically for discrete data. A histogram has no gaps, and typically for continuous data. Because for instance, if I'm measuring the length of my foot, I'm going to have a span of data. So for instance, I'm going to be measuring from people that have a foot from 5 inches to 6 inches. I'm going to have people that have from 6 inches to 8 inches. I'm going to have whatever it happens to be. So when we have histograms, so it has to start and end at certain spots. When we do though, we need to know our ending data. Where is it included? Is it included in the lower bar or is it included in the upper bar? And our inequalities will come from that. And a lot of times it'll say it in the story. So we're going to see that in example 2 here in just a moment. Like how do we actually graph a histogram when it's continuous data? So like what are we looking for? And sometimes you're going to just have to put it in your frequency table so we know, are you including that endpoint or not? Okay, but before we do that, we're going to talk about the shapes of our histograms. Okay, look at this middle one. I need you to see this middle one. This looks like a bell curve. Do you see the bell? This is called a normal distribution. Okay, so with a normal distribution, in the middle is the most amount of data, and then it tapers down. It has this bell shape. And we're going to see a lot of normal distributions in the next unit for statistics. However, our data can be skewed. And this is the start of us looking at data being skewed based on histograms. So if you notice, this bell curve is missing this right-hand side. The reason it's missing the right-hand side is this is either called negatively skewed or left-handed skewed. So this is either left skewed or negatively skewed. Because there's more data on the left-hand side and not enough on the right-hand side. It's sometimes opposite of what you think it should be, but there's too much information over here on the left-hand side. That's why it's skewing it to the left. This one looks like this curve. Again, there's too much data on this right-hand side. So this is a right or positively skewed.
When there's too much data.
Hold on one sec. Continuing on. So example 2 here, we have a group of, this is 38 teachers. It says, I think 37 in your packet, but if you count, there's actually 38. We're asked how much time and minutes they spent eating lunch at school. The raw data is listed below. Construct a frequency table for this data with classes means subgroups of 0 to 4 inclusive. So therefore, that first one we're going to count from 0 to 4. And then the next one goes from 4 to 8. We're going to include 8, but we're going to exclude 4. All of our data here happens to be integer values, but it doesn't have to be. So again, discrete data can be in a histogram. Okay, we just are grouping our data together. So in our frequency table, we've got time and we've got frequency. So in our time, we're going to go from 0 to 4, and then we're going to go from 4 to 8, including 8, and then we'll go from 8 to 12, including 12, and then we're going to go from 12 to 16, including 16. Just be consistent with which one you are equaling. Otherwise, you're going to have skewed data alone from that. So if you are including the right endpoint, keep including that right endpoint. What's really nice with this is we included 0 and included 4, but realistically, there's no zeros. So our histogram really shouldn't be skewed. Our sizes are all the same. Okay, so go ahead and count the frequency and list how many people fall between the 0 and 4 inclusive, etc. Okay, so where we construct the histogram, we're going from 0 to 4. So since we included 0 in here, when we make our bar, we start over at 0 and we go up to a height of 8. I'm going to pretend this is 8. I have no idea what this is. So 8, and then it comes down to 4. And then from 4 to 8, there's 13. So then I go up to 13, come over to 8, and come down. And then between 8 and 12, there are 10. And then between 12 and 16, there are 7. This is how you construct a histogram. Again, making sure that you have a title on your graph, which is time spent eating lunch.
Oh,
Okay, so again, we went through a lot of just general information, some vocabulary, a little basic stuff with graphs. Tomorrow we'll get into the nuts and bolts of mean, median, mode. Then we're going to move into standard deviation. And every day we're going to definitely increase in difficulty. Okay, so work on your homework for 6.1 and 6.2. And here is your homework problem.